Welcome to the ACS Technical Advisory Board podcast series, where we talk all things tech including data, cyber, AI, blockchain, and Internet of Things. Meet your host, Dr. David Cook, Vice President of the Australian Computer Society's Technical Boards. David is a technology advocate dedicated to advances and progression of computing and human-computer interaction. In today's episode, David will be talking with Professor Maurice Pagnucco on the topic of AI, knowledge representation, knowledge reasoning, and symbolic AI in a modern technical society.
Maurice Pagnucco is an expert in AI and ethics. He sits on the AI and Ethics Technical Committee as part of the Technical Advisory Board. Maurice is known for knowledge representation and reasoning in terms of artificial intelligence. Maurice, welcome to the podcast.
Thanks very much for having me, David.
Let's start with a tough question straight away. Tell us about knowledge representation. What are the challenges in terms of AI?
So knowledge representation, simply put, is how do you represent knowledge on a machine? You can think of it as a database or a knowledge base, as we would say. In fact, there are a lot of parallels between what happens in a database and a knowledge base. So the main issues are what sort of formal languages do you use to represent knowledge? So these are sort of mathematically developed languages. How expressive are they? So what can you say? What can you express with the language? They're the main issues in terms of the representation part. And I'm guessing we're going to get onto the reasoning part.
So next question. How do you reason with knowledge when you find it on a machine in that form?
Right. So if anyone's sort of done any philosophy or looked at philosophy, you'll know the Greeks sort of started this. How do people reason about their environment and so on? And as we got closer to the 20th century, this became a lot more mathematical and formalized, and we have what are called logics. So logics are just ways of reasoning mathematically. So you could think of it as just doing algebra, but the algebraic symbols stand for knowledge, bits of knowledge. You know, today is Monday. It's sunny outside. The sky is blue. So there's a formal reasoning mechanisms that would allow you to reason. And in particular, if you're asked a question, you would use these formal techniques to determine the answer to that question from the knowledge that you have.
So let's talk about something called symbolic AI and the challenge for people who constantly chase optimal behavior. Why do we make a big thing about symbolic AI? What's different?
Well, as I always say to people, I think there are two philosophical approaches to AI. The symbolic approach, which I'll come to in a moment, and obviously the non-symbolic. Sometimes it's called the sub-symbolic. So neural networks are a classic example of your sub-symbolic approach. And the reason it's called sub-symbolic is because the thinking is that in a neural network, you don't have explicitly represented symbols, but that those symbols would somewhat emerge from the neural network. And that's analogous to sort of a simplistic way that we think that the brain works. So in the symbolic AI, you use symbols, as I said, much like algebraic symbols, X's and Y's, to represent the knowledge you have about your environment. Again, what are some of the difficulties there? Well, the reasoning process for a reasonably expressive language is what's called undecidable. So if you ask a question of the knowledge base, there's no guarantee that the machine will be able to come back with an answer. And of course, you don't know whether it's gone off in some infinite reasoning chain and will never come back, or whether it'll come back in the next couple of minutes. So your ability to reason with the machine is somewhat hampered by these deficiencies.
So one of the things I know that you're on record for saying, I've heard you say this before, is that computation is the biggest unsolved problem of our lifetime. What do you mean by that?
I do say that a little bit tongue-in-cheek, but also a little bit seriously. And I do say some people think it's climate change, some people think it's cancer, but it just so happens to be computation. And the reason I say that is because when a computer scientist looks at the world, they look at problems and they want to know, how difficult is this problem to solve? Is it going to take me minutes? Is it going to take me hours? Is it going to take me days? Is it going to take me centuries? Or is it just a problem that cannot be solved in a machine? Now, mathematically, we think there's a hierarchy of problem difficulty, with each higher level of the hierarchy being more difficult. And what does more difficult mean? It means that it will take longer computationally, in the worst case, to solve problems in that class. Now, people have looked at whether it's possible to take one of the more difficult classes and bring it down to the class below and solve it in a shorter period of time. But mathematically, no one's been able to prove that. And it's called the P versus NP problem. Probably a lot of the audience have heard of that problem. If you're a computer scientist, you definitely would have heard of that problem. There's $1 million for the person that's able to solve that problem. It was mathematically formulated in the early 70s. So in 50 years, nobody has managed to solve this problem. And to me, that tells you that computation, when people think about computation, I think they think it's just about counting and calculating, and that looks like a very simple process. But this tells you that computation is much more sophisticated than we currently believe or currently understand.
I'd like to know, in terms of taking that computational challenge a bit further, because most people on social media are only really talking about generative AI and low-level kind of concepts. But I'd really like to think, what's emerging in that higher level field? Where are we going in terms of extending thinking about computation?
Yeah, look, there's quite a few dimensions to that question. I'm just going to take one of them. So there are a lot of attempts at hybrid approaches, bringing these two together. So if you look at your generative AI, large language models, they tend to be learning patterns on a lot of data, and they just follow those patterns blindly without sort of any deliberation. So on the one hand, you could think, well, that will serve you to some extent. And when things become a little bit more difficult, what you could do is switch to a more deliberative mode. So just to maybe take an analogy, this is one that's often used in the AI literature, riding a bike. When you first come to ride a bike, you tend to spend a lot of time concentrating on where you put your feet, what you do with the pedals, and so on. But as you learn it, it becomes second nature, and you don't tend to do any reasoning whatsoever. That's the sort of type of reasoning that your generative AI does. But there are times where you will need to focus and you will need to reason in a more sort of precise way.
We get a lot of international students who come through the Australian Computer Society and are interested in becoming professionals, particularly in AI. There's a bit of a change happening, I suppose, in terms of programming languages, because a lot of people previously, when you talk about what's your programming language of choice, and a lot of people might center on right now and say, Python, for example. But we're seeing a lot of people, particularly international students, coming in saying, my personal preference is MATLAB. Do you think of MATLAB as a programming language, and is it changing the way we think about programming for AI?
I'm in an engineering faculty. A lot of my colleagues in the non-computing engineering schools will use MATLAB. Why do they use MATLAB? Because it's, as the name suggests, it's matrix-based, allows you to do matrix calculations pretty well. If you look at the way a lot of the machine learning approaches and the maths around machine learning is phrased, it uses matrices because they're a convenient sort of representation for large volumes of data. And when you've got large streams of data, it's easy to represent those in a matrix form and do the mathematical computations. It sort of demonstrates the some level of parallelism that's inherent in these machine learning approaches. Personally, I would still stick with Python. I think Python has come up with much more sophisticated ways of dealing with matrices. Without going into all the detail, you'll notice that in Python, you have native arrays, you've got your numeric arrays, you've got your pandas sort of arrays that are much better for data science. So they've got different sort of matrix style representations that you can use for the specific task that you have at hand. So if it's a machine learning task, you might use the NumPy sort of arrays, but if it's a data science task, then you're going to use the pandas ones.
Maurice Pagnucco, thank you for your time today.
Great pleasure, David. Thanks for having me.
To find out more about how the ACS is powering Australia's technology brilliance, visit us at our website, Facebook or LinkedIn. Want to get involved with the ACS technical boards? Email us at tab@acs.org.au and tell us a bit about yourself. Join us for more thought leadership, ideas, and information through our other podcasts on the ACS YouTube, Facebook, or on LinkedIn.